So thank you for being here. I actually wasn't expecting that many people with like the Qt for MCU and stuff going on in parallel. I was scared it would be like Robert and me only talking about this, but it's a good thing you're here. Okay, so who am I? I've been doing Qt for a long time. In 2003, I think I started coding with it was Qt 2, and then I did that smart thing of trying to have the code compile in Qt 2 and Qt 3 at the same time. It isn't smart, right? Don't do that. But whatever. I've been working for KDE for a long time. Actually, most of the things I will talk here, I've been doing in KDE. KDE, it's a project, open source project, free software, doing desktop apps and whatnot with Qt forever. I worked in Canonical in the Ubuntu Phone project for a while until they decided we were not making any money with it and kicked us all out. And then I landed at KDAB a few years ago, 2 or 3 years ago. I have contributed a bit to Qt. It's 400 patches. It might seem a lot. I mean, it's not a lot, right? People that actually do Qt development, they have more, but it's not too bad. So I'm happy enough. One important thing, I'm not a security expert, right? I'm here as a developer that has used these tools, but I'm not an expert, right? So I know how to use them. I can explain them to you. I will tell you, but the basic topic of this talk is, this is really easy. You can do it, right? So I'm not an expert. This is not a bad thing. This is actually a good thing, right? It just shows that a regular developer can do that. I hope you're all regular developers. So which kind of security issues are we talking here, right? We're not talking about you are being bad at your architecture and you saved your password in plain text. That's a different topic altogether. That's your problem being a bad developer, bad architect, or whatever. The security issues we will talk in this session is about the things that you do because your code is bad, right? Basically around memory management, right? So you have uninitialized variables, you are using memory that you already freed, you have a buffer overrun. This is all things that happen in C++, right? This talk is about C++. It would also apply to C, right? It's not for Python. If you do Python, or you do Rust, or you do Go, or you do whatever else, JavaScript, these things don't apply, or sometimes apply, but it's not the focus of this talk, right? What happens when you have those errors, right? Most things that happens is that your application crashes. That's not too bad. But then, like, some smart people, right? I've never been able to do that, but technically, right, every single crash or uninitialized memory you have, it is a vulnerability, right? Some smart people will make your application go to some part of the memory, and they will put some other code in that memory that will make things run, and then they will delete your files, right? So that's bad. That's what we're talking about here, right? Which tools do we have for that, right? So the first tool is the operating system, right? At some point, if you are making very big mistakes with memory, your application will crash, right? The operating system will say, nope, too bad, right? The problem is that the operating system, it's sometimes a bit lazy, and you ask it for 3 bytes of memory, and it will give you like 4, because like 4 is better than 3, so here you have 4, right? But then like the 4th byte is just like garbage, and it just things that, so yeah. That's bad, right? So we have better tools for that, right? One of the tools is Valgrind. It's a great tool. It's been there forever, so you probably heard about it. And if not, you should look it up. Its main problem is that it's slow as hell, right? If you're doing something that is actually a bit expensive in CPU, it will take forever, right? I do also development of a PDF library in my spare time. You run things that, I know, the page in PDF takes 1 second to render. You run it to Valgrind, and then suddenly it takes like 30 minutes, right? Because like it is very slow. It's basically a virtual CPU, so it logs every single access you do and everything, and it just it's slow, right? So it's both slow and uses lots of memory. So, not very good. But it's really easy to use. On the other hand, right? You just type Valgrind, your app, and it will work, right? So on the other hand, that's very good. And then we have the new, right? They're not new anymore, but it's like new C++, which is like 8 years old, right? Anyhow, so we have the address sanitizer, the memory sanitizer, the undefined behavior sanitizer. They are part of the Clang and GCC, and I think MSBC is including them now too, so you almost have no excuse to not use them, right? What they do is they instrument your code in compile time. The functionality is very similar to Valgrind, so they will find any issue you have with memory. The good thing is that since they're doing it at the code level, they are much faster than Valgrind, right? The bad thing, it's a bit harder to use, right? You have to pass some flags, and it's not hard, but it's getting better over the time, but it's a bit complicated, anyhow. So, what is fuzzing and what is oss-fuzz? So what is fuzzing? Fuzzing, that's the definition from Wikipedia, I think. Fuzzing is the technique of sending random shit to your application, right? So basically what you do is you throw whatever and see if your application crashes or not, right? The most basic way is like just sending everything, right? So you have an application which is PDF info that will give you the information of a PDF file, but you start and you give it A, and then you give it B, and you give it C, and like you start giving it all the possible inputs forever, right? Obviously, that's not how you do it, but that would be a way to do it, right? I mean, this would take forever to find an error, but if you want to do it this way, like it's the first main way of starting, right? Before diving deeper, what do we want to fuzz, right? What we want to fuzz is things that you have exposed to the world, right? And by the world, I mean either by file, by parsing a file, a format parser, right? You save files and then you load them. So yeah, evil people will give you bad files to load, right? And that might do other things, right? Your network service endpoint, right? So you have a service that's exposed to the network. You get some kind of command or data through that, right? So you need to make it so that your son is called Bobby Tables. It doesn't drop the tables, right? So it needs to be like that, right? Obviously, you also need to fuzz your web browser, your email client, your image reader, but other people are doing that mostly, right? It's like we in Qt are fuzzing the image reader, and we are fuzzing web engine. Well, and lots of people is fuzzing web engine, right? So you don't need to care about that, but at most, like all of your software at some point is having an external input, right? If you have external input, you have to be aware that external input can be malicious, right? They can be trying to crash you. So that's what you need to fuzz, right? You don't need to fuzz the function that runs when you click a button, right? It's like, that's always going to be properly behaved, right? Like you are calling that function, nobody else is calling it. So, I mean, you could fuzz it, but it's not as part of the surface attack, right? Okay, so what is oss-fuzz? Oss-fuzz is something that does these things, but much better, right? Actually, the thing that is smart is not oss-fuzz. I'm going to call everything oss-fuzz because it's easier. The thing that's smart here, it's called libfuzzer, right? So libfuzzer is a fuzzing engine developed by Google. It's part of Clang since Clang 6, I think. If you're using proper Clang, if you're using Apple Clang, the numbers are weird. So it's a different number. But if you're using proper Clang, it's Clang 6. So it's there, you can use it. So what it does, it links with your code, and it's coverage-based, right? So by coverage-based, I mean it's smart enough to know if it's already going through the 2 branches of my if, and it doesn't need to do more random stuff, right? Because like it already created a random input that went through the first branch of the if, and then it created a different input that went through the second branch of the if. It doesn't need more inputs, right? It already covered all the code, so it doesn't matter if x is 51 or 52 or 53 or 54, right? For this code, I mean, maybe inside you do more things with x, but if the code was as this simple as it is, it wouldn't need to create any more random input, right? So it's like, yep, I'm done, good. What it is, it's a set of Docker images with the last version of Clang and libfuzzer. That's very convenient, right? If you try to set up these on your work machines, maybe your work machines are, I don't know, Ubuntu 16.04 or whatever, they have a very old Clang, and then you have to download Clang and compile it, and then you have to download libfuzzer and compile it. And it's like, before starting, you're already bored and you don't want to do it anymore. So they have all these as a set of Docker images, right? So you go there, do a Docker pull, you get an image that has latest Clang. I mean, it's actually more than latest. It's like development version of it and the latest libfuzzer. So you just can start writing things, right? You can start writing what you really care about and not compiling things. It's also a project in Google, in GitHub, sorry. So if you go there, github.com, Google oss-fuzz, you'll find all the projects that have submitted things for oss-fuzz. When I wrote the slides, it was 240. When I checked yesterday, it was 260, right? So it is, and I wrote the slides like 2 or 3 weeks ago. So it is growing really, really fast, right? People are starting to realize that this is a good thing and needs to be taken care of. What is also oss-fuzz, right? Oss-fuzz is a SaaS, it's like a software as a service, right? So it will do all the management for you if you are open source, right? So that the OSS means open source software, right? So if you are open source, you can submit your project to oss-fuzz and it will run your application, compile it with the different sanitizers, and it has a bug tracker linked to it. The bug tracker is very strict. It's one of those things that the security people like to do, forcing you to fix things, right? I found this bug, you have 1 week to fix it, right? It's not that bad, right? You have 3 months to fix it, right? So when it finds a bug, it will send you an email and say, yep, this crashed, or this had an infinite loop, or whatever. You have 90 days to fix it. If you don't, we will make it public anyway, right? If you do fix it earlier, it gets published a bit earlier, right? So what if your project is not open source software, right? This happens a lot, but everything in oss-fuzz is free software too. So if you want to run it yourself in-house, you can do it, right? I have not done it because it doesn't look really easy to build, and everything I've been using here was free software. So in that regard, I didn't need it. But if you need it, it's there, right? It will take a while. You'll also have to spend the computational power instead of Google doing it, right? The good thing about this is like Google has millions of computers somewhere, and it will run your programs for you. If you're not using that, you'll have to do it. But anyway, computers are not that expensive nowadays, so you know it's there. This is a bit of a diagram of how the things look, right? So you're a developer. I just copied that from their webpage, right? I'm actually worse at doing diagrams than this, even if this is not very good. So you write a fuzzer, right? We'll see what a fuzzer is. This pointer is not very good. Anyhow, you would write a fuzzer, right? So it's like a small program that tests your application or library or whatever. You give it to them in oss-fuzz. They will run it in Jenkins. They will run it, and in their cluster they have for fuzzing, they will file the bugs. It also tracks if you fix it or not. So it will, when you upload your code, it will run again tomorrow, and it will run the same file, right? That's one of the things that is important. It gives you a file so you can test, right? Because sometimes like, yeah, it crashed. Okay, why, where, right? Like that's not very interesting. So it will give you a file. So what it does is like the next day it runs the same file again and says if it's been fixed or not, and it just keeps that doing forever, right? So if you regress, it will also tell, yeah, you fixed it at some point, but it's now broken. It tracks the deadlines and tells you, right? So it's pretty simple, but interesting anyway. So we're gonna do a small example now here. This is how a fuzzer looks when you are working with libfuzzer, right? So you have a function, it has a weird name, but It's very simple. It gets data as input, right? So you get data as input, a char pointer and a size, right? So this is one of the fuzzers I have for one of the KD projects. We have, so in Qt, there's this image handling, right? And Qt itself comes with image handling for PNG, JPEG, and whatnot, but it doesn't come with a handler for True Vision Targa TGAs from 30 years ago, right? So we have one of those in KDE for the people that have very old files and want to see them, right? So we decided to run a fuzzer through it. So it's kind of easy, right? So you create your core application because you always need an application, right? You create the handler, and somehow give it the data, right? So you create the image and a buffer, and it's not very complicated, right? You open the buffer, give it, and then exercise your API, right? So you have the can read and read, right? This could be inside an if. It wouldn't be bad, but some people misuse the API, so it's not that bad that you call both, right? So that's how you would write a simple fuzzer, right? So you would have your file parsing in your application. Your file parsing at some point gets data, right? So you would replace the QImage IO handler with my file parser, whatever. Then you need to run it in Docker, right? So you have to write a bit of Docker. I've had no idea of Dockers, but it's not very hard. So you basically inherit from the base builder they have, and you tell them your email so they can email you, and then you run a bit of code, right? In this case, I need zlib, libzip, Qt itself, and my code for image formats, right? So I git clone all of that, and then I have two other files we'll see now. Well, we already saw the fuzzer file, right? That's the kimgeo fuzzer cc, and then there's a build file that basically tells how to build all of this. And building it's not that hard either, right? One thing you have to consider is that it wants everything to be statically linked. So if you have the dependencies and their libraries, they have to be statically linked because it wants to create a binary that then it will run somewhere else and it won't have all the libraries you wanted it to have, right? So, well, you just run configure or cmake telling it to build the static lib versions, right? Another thing, it's like you will give it a seed corpus, right? What's a seed corpus? It's the starting point for it to start fuzzing, right? So it doesn't have to start from A, like I started with my original file, right? You give it an actual valid TGA file and say, okay, from here, you start making random changes to this file, but from this file, right? So it actually is similar to what you expect, right? Because otherwise it might take a while for it to find valid files or valid invalid, right? But yeah, building Qt is that it's that part that it's not so easy at this point. I mean, it's not so hard either, but I have to run set through a few qmake files to make it work, because otherwise the configure fails. But yeah, we're working on that. Well, Robert is working on that. So yeah, you configure Qt. It's not terribly hard, but it takes a bit of usage to get to do it, right? How does it look like, right? So what happens when it finds a bug, right? So yeah, this is the PSD handler. We also have a PSD handler for Photoshop files. So it will send you an email, and it said it crashed, right? It's a null reference. You had a null pointer being called. It gives you an issue number, so you can go to you can go track it. And it also, like the important thing, it will give you a minimized test case, right? So in this case, there is a 27 bytes file that when you give it to our PSD handler, it was just crashing, right? That's bad. So you don't load the file, you run it, and then it crashes and say, oh, yeah, okay, whatever. how does it look like, right? So that's a basic memory sanitizer, address sanitizer, stack trace, or trace, not stack trace. So it tells like there was a segmentation fault, it went to 0, 0, right? So this was the fuzzer called read called load PSD, and then you did something in this file, in this line, and it was all very bad, right? So then you go there and try to fix it, right? You have to be sure that you don't fix it too much, right? And then stop loading files. That's the easy way of fixing things. You make everything not do anything. So yeah, make sure you have a good regression test suite so you don't fix it too much, right? So what about Qt? So Robert here will answer all your questions about Qt, but this is a bit of a summary. We are fuzzing Qt locally with libfuzzer. So if you go to Jira, there's actually a tag which is bugs found by libfuzzer, and it's not very big, but there's a few of them. So it's good we started doing that. There's a configure switch for configure to start adding the info. There's some fuzzers, both in codebase, declarative, and SVG to exercise the classes and make sure they don't crash. There is an original registration of Qt with oss-fuzz. So if you go there to the URL I pasted before, Qt is there, but then when you click it, it's empty. So we still have to fix that. But we are getting there, right? That's the idea. We're getting there. So that was my talk. We have maybe 1 minute for questions. So thank you.
Hey, Robert, you want to start first?
I don't have a question. Maybe somebody has a question to Albert or me.
Okay, I thought Robert has
a question there.
One question over there. Wait, I'm coming.
Hi. Before the whole Google fuzzing thing came around, I think the main thing people used was AFL.
Yeah.
So have you tried or compared those?
Sorry again?
Have you tried that as well, or have you compared the two, how they...
I tried using AFL. Honestly, it wasn't very easy. So I kind of failed, right? So what I wanted to make sure is having the Docker images is really great. It's a way to make it very easy. At least for me, AFL wasn't that easy to use. You had to compile it, and I got lost. I mean, I'm not saying it's better or worse. For me, it was a bit harder. This, I did it in a morning, right? I mean, maybe more than a morning, because when you have to compile Qt, it takes a while, right? So you have to sit there waiting for it to compile. So you kind of waste 1 hour between it failed and it failed again. But if you the actual work was like a morning, right?
Cool, thanks.
Maybe someone else? Any questions for Albert?
No more questions. Okay, thank you. I'll be here, so if you're scared to ask now, you can come later and talk to me. Thank you.